Okay, question 11. The first number in a pattern is 1.95, and each number in the pattern is formed by subtracting 0.15 from the previous number. And what is the third number in this pattern? So the first number is 1.95. Now we need to subtract 0.15. Number is formed by subtracting 0.15. So 1.95 minus 0.15. Notice the 0.15 is after the decimal point. So we have 1.95 minus 0.15, subtracting down in columns. 5 take away 5 is 0. 9 take away 1 is 8. Then we put the decimal point, and 1 take away 0 is 1. So we've got 1.80. And for the third number, it's 1.80 minus 0.15. I mean, you can set it up as a subtraction as well, or you can see that you're taking the 0.15 will be under the 80, under the 80. So you will end up with 1.65. So 1.80 minus 0.15. So subtraction, look at it, is easier if you know that these are both under the decimal point to do 80 take away 15, which is 65. However, if you want to use the algorithm, 0 take away 5 can't be done. So we take 10 from the tens column. So we've got 10. Take away 5 is 5, crossing off the 8 and replacing it with a 7. 7 take away 1 is 6, and the decimal point, and 1 take away 0 is 1. But it would be easier to notice that the 80 and the 0.15, or the 15, you could say, are after the decimal point. So you would just be doing 80 take away 15, which is 65. So therefore it would be 1.65. Okay, which is circled there. Okay, now the athletics carnival started at 10:30 and lasted for 2¼ hours. Rose went straight home after the carnival finished, and she took half an hour to get home. What time did she get home? Now you can draw a little timeline here if you want. So if we're going from, I'll just show it all. So 10:30, we need to add 2¼ hours. So let's just add 2 hours first. So we've got 10:30, then we jump to 11:30, 12:30, that's our 2 hours. Then we're going to add 1/4 hour. Now 1/4 hour is 15 minutes. So 12:30 plus, we have to add 15 minutes onto the 30 minutes, which is 12:45. Then a half an hour to get home. Now a half an hour is 30 minutes, which is really 2 lots of 15 minutes. So from 12:45 we go to 1 o'clock and then to 1:15. So therefore Rose would get home at 1:15. Now making sure that that's 1:15 p.m. So because we end up in p.m. time from this 12:30, so this is the afternoon, ending up with 1:15 p.m., not 1:15 a.m. We can do this. So AJ paid $18.60 for 6 high bounce balls, and we have to find the cost of 1 high bounce ball. Now remember, this is a non-calculator section of the paper, so what we want to do is $18.60 divided by 6. Now remember, you don't have a calculator. What you could do is do the dollars and the cents separately. So 18 divided by 6 is $3, and the 60 cents, the 0.60, is 60 cents, divided by 6 is 10 cents. And so if we add the $3 and the 10 cents together, we end up with $3.10. So therefore the cost of 1 high bounce ball, so we've got the $3 plus 10 cents, writing it here in dollars, so 3 plus 0.10 is $3.10, so the cost of 1 high bounce ball is $3.10. Okay, question 14. William earns money each week for doing jobs, and for each job he earns $2, and he records the number of jobs he does in 1 week in the table below. So taking out the rubbish 3 times, walking the dog, that's 5, 6, 7, 5 there, 6 times, and washing the dishes 4 times. Now, if William does the same jobs for 3 weeks, how much will he earn altogether? Now, let's just have a look at 1 week first. So the total jobs in 1 week is 3 plus 6 plus 4. Now, 6 plus 4 is 10, plus 3 is 13. Now, remember, he earns $2 each job. So what he earns in 1 week, the amount earned in 1 week, is this 13 times $2, which is $26. However, he does this for 3 weeks. So please read the question very carefully. Notice there are answers of 13 and 26, which are answers for part of the way, part of the working out. So the amount earned in 3 weeks is 26 times 3, which is $78. Now we can do 26 times 3 in a number of ways. The first method here, you could use the algorithm if you wanted. So 6 times 3 is 18, put the 8 there, carry the 1, and 3 times 2 is 6 plus 1 is 7. However, another way you can do this is a calculator. Another way to calculate 26 times 3, you would do 20 times 3 is 60, and 6 times 3 is 18, and 60 plus 18 is 78. So the answer there is 78, okay? Okay, question 15. Tom joins a gym that has a monthly fee of $56 and members pay an extra $6 per session if they want to work with a gym trainer. So which expression represents Tom's monthly gym bill if he works with a trainer for X sessions during the month? So remember, the monthly fee is definitely $56. Plus $6 per session. So $6 times the number of sessions, not 6 times the number of sessions. Now, for example, if there was 1 session with the personal trainer, it would be $56 plus 6 times 1. That's if there was 1 session with the gym trainer. If there's 2 sessions with the gym trainer, the cost would be $56, that's the monthly fee, plus 6 times 2, and so on. If the person had 3 sessions with the gym trainer, the cost would be $56 plus 6 times 3. And 4 sessions, and so on, $56 plus 6 times 4. Now, instead of, so if we let the number of sessions equal X, the cost will be 56 plus 6 times X. So it's 56 plus 6 times X. And remember, with algebra, you can, with algebraic expressions, we do not need this multiplication symbol. 6 times X can be written as 6X down here. So the monthly fee is 56 plus 6X, which is, so that's the fourth response here, 56 plus 6X. Okay, question 16 says the table shows the fixtures for 6 football teams on Saturday. We have Team A playing Team B, Team C playing Team D, and Team E playing Team F. And none of these matches ends up in a draw. So that means someone must win and someone must lose each game. And the question is, which of the following is possible? Now it says teams A and F both win. Yes, that's possible, even though we don't know what's happening with C and D. So this is a possible answer, okay? Teams C and D both lose, but C plays D, so they both can't lose because one of them, only one of them must lose and the other one must win. So that's impossible. A, D, E, and F all win. Now, A can win, D can win, but both E and F cannot win. So that is impossible, okay? So impossible as E and F both cannot win because either one of E and F must lose, and B and C are the only teams that lose. Yes, B can lose and C can lose. However, E or F must lose. So impossible as E or F must lose. So even though at first glance it appears that none of these are correct, the first one is possible, even though they don't tell us what happens with C or D, but it is true that it is possible that both A and F can win. So that one is a little bit of a tricky one. However, the reason you know that that's the correct answer is because the last 3 answers are definitely impossible, okay? And it doesn't say that only A and F win. It just says that A and F win. It just doesn't mention what happens to C and D. Okay, question 17. A class had a cake stall and they sold 100 cakes for $7.50 each. What is the total amount that the class can make from the stall? So we have to multiply $7.50 by 100. Now to do that, remember the decimal point is between the 7 and the 5, and to make this multiply by 100, we're making it 100 times bigger, so we move the decimal point 2 places to the right. So for example, if it was 7 times 100, your answer would be 700. If it was $8 times 100, your answer would be 800. So it makes sense that $7.50 times 100 is $750. And as I said, to multiply by 100, you're making the number, your original number, 100 times bigger, and we do that by moving the decimal point 2 places to the right. So we start with $7.50, then we end up with $75 and $750 when the decimal point ends up at the end there. Okay, now for question 18. Liam had a leaf, and here is the leaf, and he reflected the leaf to the right across the dotted line. So if we reflect that, so that's flipped over, we will end up with the leaf that looks like this. However, he then rotated the leaf 90 degrees clockwise. Now I'm going to rotate this 90 degrees clockwise. So we spin it clockwise 1/4 of a turn. Remember, 90 degrees is 1/4 of a turn. So you can see the 90 degrees coming up here. It's 1/4 of a turn. So then we end up with the leaf looking like that, which is this one here. Okay. The last leaf there, that is the final position of the leaf. Reflection, and here we have the rotation clockwise. Here's the reflection, and this is the rotation clockwise, so it would have to spin around like that.